Alrighty. So folks, remember, you don't have to pay attention, but don't be a distraction, okay? These, I know you won't see. You're adults or semi-adults or something on that spectrum. So. Alright, so we're going to start with number 5 here. Clock on the spaceship moving with this speed, I'm assuming relative to the Earth, or someone at rest, advances by this. How much time elapses for an observer at rest? Alright, so that would be the time on the ship. So, does more time or less time pass on the ship, as observed from the outside frame of reference? Less time passes on the ship than for the outside observer, because moving clocks move slow. Alright, so we should have that in here. We should probably start with our main thing, that it's constant from all frames are, and then something like moving clocks move slower since less time passes. Right? And so you might, and then you want to tie it to this problem. So more time passes for the observer. Did I tie it back to this exact problem? Yeah, with that statement, right? These two are very general. All right. You should look at our equation sheet, and they asked us about time. So should we use the equation for time, length, momentum, mass, or relative velocities? Probably the one for time, because they mentioned time a bunch. And so we have T equals gamma T naught. And we know gamma is always greater than 1. So what's the relationship between T and T naught? T is always greater than T naught because we know that lambda is always greater than 1. And so that allows us to say, oh, wait a minute, if T is greater than T naught, which frame of reference experiences more time? The one at rest or the one moving? The one at rest. So T must be at rest, and T naught must be moving in this case. We should probably also have grabbed gamma, which is 1 over the square root of 1 minus, and I like to write this as V over C quantity squared. I just find that is, for me, easier to think about. Because they, like in this one, they tell us that V is 0.895 C. So V equals 0.895 C, then V over C is just 0.895. I try to avoid having to use the value for C as much as is humanly possible, because that's a big number to substitute in, right? So if I can keep things in terms of C, that makes me happy. All right, so now all I have to do is substitute in, right? I'm looking for T. They tell me T naught, and now it's just algebra. So I'm looking for T I know the T naught for me is 13.2 seconds. That ends up over my substitute in, right? Yay, done. And there was much rejoicing. And because it's Friday morning, I better throw it in my calculator and make sure that I'm not having Friday brain. No, I never had C in there. Yay! I knew I could do it. So, number 9. A rectangular painting of this and this. Okay. At what speed v must the painting move parallel to its width to appear to be square? Oh. There's just a part A. Okay. All right. So I think there's a couple of key understandings here in number 9. Anyone pick out a key understanding that would be good to make sure that people knew we knew?
Length contraction only happens in one dimension.
Excellent. Excellent. Length contraction only happens in dimension of motion. Okay, if I modify that a little bit?
Yeah.
I think there's another simple fact that probably most of you wouldn't think of expressing, but might be a good thing to have in the Y. Something to do with shapes.
A square's height, no, width is equal to 1.
Yeah. I thought about it as all 4 sides of a square are equal. Yeah, I think that's the, and that statement is what ties it to this problem, right? The other 2 are generic, could be any length problem, right, Kevin? This one ties it to this problem. Good. So, need some equations again. Let's see. No, we're going to need gamma. And then we should have that L equals L naught, weird L naught, over gamma, right? So what's the relationship between L and L naught? Given that gamma is always greater than 1.
Oh yeah.
Think about putting 2 in for gamma. You'd get a smaller number. Well. All right. So that means that this will be when it's a square, and this is when it's a rectangle. Right? Yes? And when it's a square, it's 76.6 centimeters in length. So 76.6 centimeters equals, when it's a rectangle, it's 118. And then that's just 1 over square root of 1 minus. Now, if you solve for v over c, rather than solving for v, you're going to get a number that really is your answer. Because look, they're looking for v in terms of c. So v over c is some decimal, 0 point whatever. Well, v equals that same decimal times c. So by solving for v over c, you're getting the value, you're getting v in terms of c. So that's what I would suggest, rather than solving for it and then having to keep, solve for v over c. And so just a little algebra and you'll be there. Should you get a number less than or greater than 1? Less than 1. Because if you get a number greater than 1, you're not in this universe. You switch universes, which is not what we want to do in this problem. We want to stay in this universe. Sure. Yeah. Or you could do a little algebra. Either way works.
I'm trying to do the
I understand. Yeah, you can solve for. I'd probably simplify it slightly. My square both sides, get rid of the square root.